Hello. I think you are not audible, madam. You have muted your yes.
Now I am audible, sir.
Yes, yes, yes.
Okay. Thank you, sir. It's my great pleasure to introduce to our today's speaker, Sandeep Borgaonkar, sir. Sir has a 10-year experience as a professor in Pimpri Chinchwad College of Engineering and Research. Sir worked in the field of star formation from 2010 in Tata Institute of Fundamental Research, Mumbai. Sir registered his PhD in Pune University. He worked in many projects and he has published many papers. I will request sir to take charge of session. Thank you.
Thank you, madam.
Thank you, sir.
So first, I would like to ask if there is any, you have tried the assignment and so anyone has any doubts in the assignment, just 5 minutes. We'll have a doubt clearing session afterwards, but just preliminary doubts, anything regarding, you can write in the chat box or something. You are getting everything. The result is your PDF file is generated and all those things.
Sandeep, sir.
Yes.
Please on your video, sir. Up the screen.
Okay. Okay. So
Yes.
just a minute. So anyone has any problem regarding whether they are not getting assignment or something like that? Anyone? So you can ask if some small doubts are there, you can discuss now. In detail, if you want to discuss, we'll discuss in the doubt clearing session. So if no doubts, then maybe we'll start. And so today's topic yes. Yes.
Sir, alignment of figures. There is a doubt in alignment of figures.
Okay. So alignment of figure is, so there is no direct command that you tell that you have to align the figure. Either you center the figure or you adjust your size or you adjust the space in between. So if you had noticed when that example which I have given, between two subfigures, I have written that /h fill. So the /h fill tells that the figures should be as much separated from each other as it is possible. And if h fill is not working, then you manually give some space. So maybe I will discuss how to give space in between your topics. In between your lines, vertical space, horizontal space, you can give in centimeters or inches. So that you had to do manually. There is no direct command or something like that for that.
Okay, sir. Thank you.
Yes. Anyone else? Okay. So if not, then what we will do is, I think we'll start our today's topic. So I think someone has requested how to, in general, write a complete research paper. So that we'll see afterward. But what I will do is I will try to cover the mathematics part, because figures and tables we have completed, and how to typeset mathematics that we have to do. So let me just share the screen. So everyone is now comfortable in overleaf. I think you have practiced. So what we will do is we will do some mathematics part today. So let me erase this. This was yesterday's file. Okay, so let me start by introducing. So when you have to type mathematics, there are something called math environments that you have to use. So there are 2-3 different types of environments. Some environments or some commands you can use without any additional package. But for certain environments, you will require additional packages. There are a lot of math packages. You can Google it afterwards also. But today I will try to cover whatever we can do without using any external package, simple maths things. Okay. So let me first introduce you to this math environment. Okay. So let me type, you can also type this side by side. So let me type a sentence. Hi, this is a LaTeX learning session. So I have typed a simple sentence. Right now I have not given any full stop or anything. So this is a simple sentence. Let us compile this sentence and see what we get. Okay, as expected, you will get this is a LaTeX learning session. Now what I will do is I will write a dollar here, and in the end I will again type a dollar. See if you are also getting it simultaneously. Okay. Now let me compile it. Now, what is the difference in the first case and the second case? What I will do is I will type the same thing again so that you are able to see this difference. Okay. Let us compile this and see what is the difference. Maybe I will have to give the 2 lines for new sentence, new line. Yeah. Now can you tell me what is the difference between these two? The first, it is appearing as we have typed it. So there is a space in between. We have not given any particular font, any italics or any slant or something like that. So therefore what we are getting is a simple upright font. This is a LaTeX learning session. Now the second case, what I have done is I have given $2 and I have a dollar sign and I have typed my sentence in between the $2 sign. Now when I compile this, I am getting everything in italics or something like that. There is no space, anything, nothing. Okay, so it is not even identifying the space in between. Okay, let me just, okay. So let me just do one more thing, or maybe afterwards. So this second thing in between dollars, this is called mathematics environment or math environment. So in between whatever you type, it is considered like a type of variable. There is nothing calculation or anything we are going to do, but the formatting that the LaTeX has decided is like a formatting of a variable. Okay. Now specifically, I am pointing you to the X in the LaTeX. In the first part, it is a simple Roman X that you are seeing, whereas in the second part, you can see that the X is italics or Roman type, the one which we use for a variable. Okay, so this is basically what is a math environment. So whatever you have to type in this, you type in your $2 signs. Okay, so now what can we do in this math environment? So there are some new things which we can try in this math environment. Okay, so what are these math environments? So let me just give one or two examples. Okay. So in addition to this, let us type something else also. Let me type X space equal to space Y. And let me type the same thing in the math environment. X space equal to space Y. Now let me see what we get. So you see, in the second type, the equal to sign is also completely different. It is a proper formatted sign. The two variables X and Y are proper. The equal to sign is also in the center of the two variables. So this is a specific math environment which has been designed for mathematical symbols, mathematical equations, and like that. You can also try this side by side. You type something in the dollar environment and see for yourself. I'm not using any new package or something like this. You want to type this simultaneously, you can also type it. Okay. So now let me just, before we go further, discuss one or two points. There are certain things in this math environment that you can do and you cannot do. So for example, as I said, that whatever you type, it is getting in a special italics or variable type font. Suppose you want this vertical Roman font as it is, then you will have to write something like this. Math RM. you write here curly braces, and then you say hi. Okay. And for comparison, let me write hi outside. So let us see what we get. And also for comparison, let me write hi here. Now let us compile this. So see, suppose in the first case, without any math environment, you are getting a proper upright font, HI. The font, the hi written outside the math RM is again italics, like we have discussed till now. But the font which is written inside the slash math RM is upright, like it is without the math environment. Okay, so it means suppose we are writing equations or we are writing this math environment, and suppose we get a requirement that we have to type upright font, we can use this math RM command. So whatever you type inside the math RM will be like without the math environment. मतलब math environment के अंदर अगर हमको normal text type कुछ लिखना है तो वो हम slash math RM use करके लिख सकते हैं. Now next thing which you also have noticed is that there is no spacing by default in a math environment. Hi, and suppose I give here space, hi and hello. And here suppose I give a space, hi and hello. If I compile both the things, in the second, there is no space. Now suppose you have to give a space, then what you do? So there are certain things. What you can do is, after hi, let me give a backslash and let me compile this. So if you see in the compiled PDF file, you see that there is a space between the I and A. So one space is generated. Now suppose you want a little more space, little less space, then what you do is, हमको इससे थोड़ा कम space चाहिए, then you use this exclamation mark. So I am giving you 2-3 parts of this spacing. Now you see that पहले जो space था, now I and A are overlapping on each other. What I will do is, let me give it on a separate tab so that you will be able to see it properly. Yes. So now if you see, normal I and A के बीच में जितना space है, a lesser space is generated. So this is called negative spacing. Okay. So backslash and exclamation mark is generating a negative spacing. Okay. You can type this yourself. I am just discussing this. So first is backslash, a simple space. Then next is negative space, that is exclamation mark. Now, if you want to generate a little larger space, then backslash and comma. Let us compile this. I have to. Let us compile this. I and A, इसके बीच में थोड़ा सा ज्यादा स्पेस जनरेट हो गया है. Even more अगर हमको स्पेस जनरेट करना है तो we use colon. So what do you get? Let me compile it. So अभी थोड़ा स्पेस ज्यादा हो गया है. I will give you examples. And now let us use semicolon. So even thicker space will be generated. So here a larger space is generated. So I and A are separated more and more. Okay, so you can try this one by one. So what I will do is, I will do this one by one. A slash negative space A slash space A slash comma A backslash colon A and backslash semicolon A. So let us compile this one by one and let us see what you get. Okay. So you see this, that the space has slowly started increasing one by one. Negative space, space, smaller space, greater space, even greater space. There is a very small difference, but that difference is visible when you go in the your equations. Okay, there it will be visible. So you also try this simultaneously. So you are expected to do this simultaneously. Anyone is not getting it? Just half a minute. Let us take a break. Do it on your own. Then we'll start. Okay. So now this much, I think now you are comfortable about the math environment. What is the difference between the usual text and the math environment? So now what we will do is we will try how to do different things in this math environment. Okay. Now suppose you have to write. Now there is a constant in physics which is called Avogadro's number. Okay. So let me write it here /math rm Avogadro's number, and let me type here n underscore a, okay, equal to, the final output will not give me space, but just for my understanding, I am giving here space 6.023, okay, slash, let me use into simple x. Let us see what we get. Into 10 raised to 23. Okay. So आप सबको Avogadro's number शायद पता होगा. Let me just search on Google and Avogadro's number. Okay. So what is Avogadro's number? Images, let me. Okay. This is the number 6.023 or 6.022 into 10 to the power 23. Okay. Now we have to write this number in LaTeX. So how will we write it? So in this manner. Now let us first see the output. Then we'll see what corrections we are supposed to do. So can you read this, what we are getting? Avogadro's number, correct? उसके बाद space आया नहीं. Then NA equal to 6.023. हमको into चाहिए था, we required into, but we are getting this variable x. 10 raised to 23. इसमें only 2 has come in the superscript. Everything else, that is 3, has gone as a normal font. Now, what are the changes that are required? So let us see the changes. First, let us give a, just for convenience, a colon here. Let us give a small space. Okay. NA equal to 6.023. Now, in maths, suppose you have to use these symbols. You use slash times. Okay, matlab multiplication. Now, if you have to write subscript, you use underscore. If you have to use superscript, you use this triangle shape. Okay, this arrow which is there on your keyboard in 6. Now, if more than one characters is there, what you do is write a curly brace. Now let us see here what we get. Now is this good? NA equal to 6.023 into 10 raised to 23. So I hope you have understood. I think you type it and see whether you are getting this result. You can copy this. You can also give a space here again. So you can copy this and see if you are getting the result. And you can communicate. If you feel there is a problem, you can communicate. So is everyone getting it? Yes. So now what is the first rule that we have learned in the math environment? That suppose you want subscript, you use underscore. Suppose you want superscript, you use this triangle. Suppose there is more than one character that you want to put in superscript or subscript, you should put a curly braces. Okay. Now what we will do is we will learn about some symbols in maths. So in maths, there are a lot of symbols that we can use, nice, beautiful symbols. Suppose you have to type a Greek letter. How will you do that? Suppose word is there, you go to insert symbols and then you insert that symbol and something like that. Okay. But suppose here you want to use Greek letters, how you do it? Suppose I want to use delta. Okay. How will I use it? Slash, and I will type the spelling delta. Correct. Now I am seeing two options. One is a delta with a small d. One is a delta with a capital D. So first we will do the small d and see what we get. Control S, I am compiling. What do I get? I get this symbol, small delta. Just a minute.
Hello, Mithile madam. Namrata madam. I'm audible to you. Namrata madam. Hello.
Sir, you are audible, sir.
Ha. I'm Shital Patil. Sandeep sir will
Yes, sir.
continue remaining lectures from my login. Okay. So
Okay, sir.
please unmute Shital Patil. Okay. And you can mute Sandeep Borgaonkar sir. Sandeep Borgaonkar sir will continue from my login.
So
Okay.
host will be
Sandeep sir only.
okay.
Only he will work from my login, from my
Okay.
PCA, in fact.
Okay, sir.
Hello, am I audible?
Yes, sir. Yes.
Actually, they are trying to unmute me myself. I am also Shital Patil.
Acha, okay, okay, okay.
So I got that message.
Okay.
Uh,
Sir,
this,
you log out for some time. Again, log in. That will be the better option, I think. Only 40 participants are there.
Hello.
Ah, madam.
Sir, both Shital Patil I have made. Is it okay that sir also I have? So he will not unmute. You can continue, sir. Please check it out.
Ah, okay, okay.
Sir, is it able?
Hello, are you able to hear me now?
Yes, sir.
So I'm just taking it from Shital Patil sir's login. So there was some issue, technical issue. Okay. Yes, so sorry for the disturbance. So let us quickly come back to our session. So everyone has tried this /math rm Avogadro's number. Are you getting this Avogadro's number properly now? Screen share. Okay, sorry. The screen share was not. Let me share the screen. Yes. So are you able to see the screen? Yes, I hope you're able to see the screen. Hello?
Yes, sir. Able.
Yes. So have you tried this? Yes. Others, all participants? Okay. So now, as I was telling you, so in this maths, normally when you type in words, you have to go in and insert symbols. So here you have certain commands for these symbols. Okay. So there are a lot of symbols are there. So I will not, I cannot go through all the symbols. So let us just see a few symbols and see which we use every day. So the first one was what I was telling, that suppose you have to type Greek letter. Okay. Suppose you have to type delta. Okay. So you type simply delta and after the backslash. So first you type backslash, after that you write delta, and you see that you are getting this small delta. Now suppose you want to make it capital delta. So let me just give a small space here and say slash capital delta. So what do I get here? Let me compile this. So what am I getting? Capital delta. Okay. So in this manner, this Greek alphabet. So the first thing which we now have seen is that Greek alphabets. Okay. If you have to write Greek alphabets, there are two ways: small delta, capital, small letter, capital letter. And suppose you have to write capital letter, you can simply write the capital D in the beginning. So similarly, you can try for some other letters. So let us say that you are writing phi. Okay, let us try phi. So instead of delta, let me copy the whole thing. Let's say phi. Okay, so what is the spelling of phi? So this second backslash after delta is not a part of the command. It is just for space. So if you don't give it, it will not give space. So therefore I am giving it. So let us say small phi. Let me ignore the second and let us compile it. What you get? Phi. So you're seeing this, you get that phi. Okay. Suppose you want capital phi in potential and something like that. So just make it capital P and let us compile it. But you get capital phi. See that space is not there, so therefore I was using this backslash. So again, let us compile so we are able to see properly. So you see the difference, small phi, capital phi. So all that Greek letters, you can get small letter, capital letter. Let us just try a couple more, then we'll go to the next symbols. Let us see, I think a usual letter which people use is gamma, G-A-M-M-A. Okay, it is, and if your command is correct or not, you will immediately get, like overall if you're trying, you will get, they will give a command, autocomplete option. From that you can immediately see that. So gamma, let us compile this, what we get. You see that? Small gamma, capital gamma. So in this manner, you can type your Greek letters. Now, what is the beauty of this dollar math environment? It can be used anywhere. In text also you can use. So for example, let me give a backslash here. Let me write this sentence. Let us consider the density of water is, now you use math environment, okay, dollar slash rho equal to, let me give a space, 1 gram per cc. Let us combine it. What you get here? Let us consider the density of water is rho equal to 1 gram per cc. Now, of course, you can write it more properly if you want. If you want the units to be not in italics, then you can certainly write math rm, curly brace open, curly brace close, and you can write it here. Then if you want space after 1, acha nahi dikh raha hai, then you can use backslash, control S. So let us consider the density of water, rho, is 1 gram per cc. Okay. So I think you also try this, something like this. You can write your own sentence. You can try your own thing. Are you doing it? There is the participants. Yes. So if you have any problem, you can, if you're not getting it, you can just tell me. I am coming to everything, Kumar sir. Yes. How to insert integration, derivative, all that. We'll go to that step by step. Lot of things are there. We'll go to that step by step. Okay. So this is one thing. So you just try this. Now, in mathematics, let us start from the simple this thing. Simple objects. So let me erase everything, or maybe let us keep it here. Let us go to next line. Let us say I want to say x equal to y. So x, I will type equal to keyboard, the equal to sign on keyboard, x equal to y. Then you get it here. Okay. Now suppose you want to type x greater than y or x less than y, you can in again dollar sign, you can say x. You can use something which is there in the keyboard itself. X greater than y. Then let us say x less than y. Okay, and let us say this. So what you are getting? X equal to y, x greater than y, x less than y. Just note that this greater than and less than sign, you know, the shape and everything, the position and everything, it is very proper. Okay, the xy is exactly in the center and all this. So even here it is looking different, greater than, but when you type it in a math environment, it takes a particular shape. So greater than, less than, something like that. Now, yes, suppose you want to use plus sign. Okay. Yes, x. So use simple plus sign from your keyboard. And if you want to use minus sign, then you can again use simple minus sign from your keyboard. So let us see this. x equal to y, x greater than y, x less than y, x plus y, x minus y, etc. Okay. Now this was straightforward. Now suppose you want to use a multiplication sign. So there is no multiplication sign on the keyboard, right? Whenever you have to do multiplication, you use that asterisk or star. So for that you have this times. So x slash times y. Okay, you give a little space, otherwise it will consider it as a command and it will give an error. So let us say x times y, what you get? You also try this simultaneously, so you are getting this multiplication sign. So if you want a multiplication sign in LaTeX, it is slash times. I am of course not discussing all the symbols, just some important everyday symbols that we use. Now suppose you want to use x divided by y. Any guess? Any guess? What will you guess? Which sign? Yes, anyone? X div div y. Okay, so it is giving you x divided by y. It's simple, it is intuitive. Now suppose I want to use, in some mathematics expressions, you have this plus minus. Okay, so x slash pm y. Okay, so you use x plus minus y. Okay, suppose you want to use, instead of plus minus, you want to use minus plus. So what you do is x slash mp y. Then you get minus plus. Okay, maybe there is some error here. Yes, minus is there. I am not able to see it on my screen, but I hope you are able to see that. Minus plus. Yes. So let us take 30 seconds and you try this yourself. All these commands, whether you are getting it. Simple commands are there. Yes. Is there any problem with anything? You are also getting it. I am. So you can write in chat box if you don't get anything. Okay. Just take 30 seconds. Try all these commands. Then we'll go to the next part. Now, in mathematical expressions, lot of times you have to use not equal to, not less than, not greater than, something like that. Okay. Yeah. Before that, one more thing. Now, while I mentioned this greater than, less than, there is also less than or equal to, greater than or equal to, something like this. Okay, much greater than, much less than, and all those signs are there. So quickly, let us see this, how we write this. X slash less than or equal to, give a space, y. Okay, so I have typed the command slash le. So you get x less than or equal to. Then similarly, greater than or equal to, if you want, x slash g equal. Okay, not ge, but g equal y. Okay, x greater than or equal to y. Suppose you want to write x much less than or x much greater than y. So let us say x slash LLY. Let us compile this. Okay, much less than. Then let us try much greater than. So x slash GGY. Are you getting it? Yes. Okay. So in this way, these commands are there. Okay. Now let us see. In maths, many times what you have to do is you have to say not less than, not greater than, not equal to, something like this. So for that, there is this slash not command. So let us see how to use this. So x slash not, then we'll type equal to, then we'll type y. Let us see what we get. So we are getting it x not equal to y. So whatever command, you just replace slash not and you will get that. So we'll start from each of these. Slash not, okay, slash not, okay, slash not. I'm just editing, okay, plus minus, it does not apply, division, it does not apply, okay, slash not, slash not, okay. So let us see this compilations. Okay, again, हर जगह पे, everywhere, not equal to, not greater than, not less than or equal to, not greater than or equal to, x not equal to, yes. So in this manner, you can manipulate these different things. Just one note that there are some specific, so for this not equal to, many times it is used. So they have made a new command for that. Instead of writing slash not and slash equal to, you can just write slash ne. Sorry, not this. I was talking about this command. This not equal to, there is a new command that they have made because it is used a lot of times. So you don't need to do that. And let us say Control S. So you are getting the same result without using slash not and equal to, just put slash ne. Just 1 minute. There is just okay. So have you tried all these commands? Okay. If you have tried this, let us quickly go to certain other symbols. I hope you have tried. Any doubt anyone is having? Okay, no. Then let us type certain other symbols. So what I will do is I will erase this. There are some special symbols in maths which are required. For example, infinity. Okay, maths people maybe like infinity. A lot of times they use it. INFTY. Am I right? Yes. Slash infinity. Correct. So we are getting this infinity. Then there is another common symbol which is used. Slash star. Okay, so you are getting a slash star here. There is again a similar symbol to slash star, which is slash asterisk. So there is a subtle difference between the two, star and asterisk. Maybe because let me just try this in a separate tab so that you are able to see properly. See these two symbols, slash star and slash asterisk. So it is given a completely different result. Okay, you can also try this. Then in mathematics, I think this is now specifically about mathematics. Other things are general, people also use. But there is a concept called complex number or square root of -1. It is normally given as a script I or a different type of I. So that is given by this. So if you write I, it will be a different this thing. If you write slash I math, this is a symbol for the complex I. Let us write this. Let us see what we get. See this, the difference between the two you see. So suppose you want to write this complex number, you can use this particular I. Now in electrical engineering, people use J instead of I for complex number. So for that, they have also given a J math. Let us compile this. Let me put a space here. J math symbol, correct? It is a different J. There is another symbol for complex number. It is called /iota. So if you use this /iota, you will get this particular symbol. A slash. So all these three I's are different. Simple I, /imath, and /iota. Okay, so you can use a lot of options are available. Yes, another thing which you use normally is, suppose I want to write this equation cos x. Okay, cos x. Let us see what we get. Any guess what we will get? So if you type cos x, what do you normally get? Now it will give C, O, S and X. It will treat as the same thing. But we know that cos x means cos is a function and x is the variable. Okay. So for that, how to take care of that? Put a slash here, /cos, give a space. And now let us compile it. Okay. So what do you get here? Cos x. So this cos has now become upright. So it knows that cos is a function and x. So these few functions, you can just say slash and write those function and it will give you a proper function appearance to that particular cos. So similarly, you can do it for /sin also, /sin x, then /log x. Just a minute. /log x. Then what else? Anyone wants to suggest any other function? Yes. /tan x. Okay. Then /cot x. Sorry, x. Then similarly tan h. Whatever it is you want to write. So let us compile it. So what you get? Cos x, sin x, log x, tan x, cot x. So you are getting cos and that particular variable, sin and that particular variable, log and that particular variable, tan and that particular variable. Similarly, cot and that particular variable. Okay. Now notice, I want to remind you that it does not mean that you write a slash and it will become upright. ऐसा नहीं है. It is a particular command which has been designed for the cos function. Okay. So suppose I write something like cos, sin, then there will be error or something like that. Okay. So it is only designed for this cos function, sin function, log function, etc. You cannot write anything using this particular thing. अगर आपको वैसे upright करना है तो I have given you the trick /mathrm and then you write in braces. So this is one thing. Okay, so till now everyone has got how to write different things in maths. Yes, you can try this. Maybe we'll wait again 30 seconds. You try all these things. I hope you will get. Sorry. Okay. Now, there are certain other functions, okay, which are there in this maths. Okay. You know, this set theory and all these things, it uses a lot of arrows. Okay. So for that, there are these arrow commands. So let us say /right arrow. So what do you get here? You get this slash right arrow. Okay. So maybe say X maps into Y or something maths people use. Now I also don't know that. Slash right arrow Y. Let us compile this. X goes to Y. Okay. Now suppose you want double arrows. Okay. What I will do? Any guess? You make this R capital. Okay. You get this double arrow. Same thing you can do for left. Maybe I will copy it here. I will copy each of the things. Then slash R. Then suppose, yes, you want left arrow. Any idea? Anyone can guess? You write L-E-F-T left. Okay. And if you want left double arrow, then you will get L-E-F-T left with a capital L. Okay. Yes. So everyone is eager about integration differentiation. So we'll come to that. Still we have half an hour and maybe we can extend 10-15 minutes. So let us, yeah. You see this? Right arrow, right double arrow, left double arrow, something like that. Same thing you can do with up arrow, down arrow, etc. Okay. Now suppose you want a long arrow. Okay. So let me just write here long arrow. So let us do this. Next line. Let us put a long on this side. L-O-N-G. Long right arrow. Okay. And what I will do is I will put a long. Yeah. Recompile. So you see this arrow is long now. If you want to make a long double arrow, then you make this right small and you make the L capital in long so that you get this L capital. Okay. So you X long double arrow and then Y. Now many times I think maths people also use this bullet. So this X slash bullet Y. Yes, X slash bullet Y. So I hope you are now comfortable with how to form different products and different things. Okay. So this is basically your math environment. Okay. Now, as I have told you, this math environment is actually inline math environment. Okay. So what does it mean? Whenever you write something, it will not create a new line or something like that. For example, this is an inline math environment. New line will not be created or centered. The equation will not be centered or something like that. Okay. So let us say, recompile this. This is an inline math environment. New line will not be created or centered. So here X goes to Y, X. So everything is in one line. Here I have broken the line, therefore there is no, so I have written this double, no? Double backslash. If you compile it, you will see that everything comes in one line. So this math environment is basically designed for one line. So if you want to write something in a line, so for example, as I had given the example earlier, the density of water or water is 10 raised to 3. So I put this here like this, dollar kg per meter and then $, raised to 3. So you'll get something like that. Density of water is 10 raised to 3 kg per meter cube. Okay. So basically, to create inline mathematical expressions, you have this particular environment. Now, suppose you have to write equations. This environment is not suitable for equations. Suppose you have to write equations. How will you write the equations? So for that, there is this environment which we denote like this: slash open square bracket slash close square bracket. Okay. Now, like in C programming or some other programming, it is very recommended that you actually write it something like this and write your expression in the center, start your alignment after the square bracket. So just recommendation. So this is not an inline. Let us say this is not an inline environment. Yes. Now let us type an equation, maybe equation of a wave y equal to f of x. Okay, let us compile this. Okay, y equal to fx. This is a very clean, beautiful equation. Of course, this is not numbered. So this environment, what we learn, this environment is for unnumbered equation. Specifically for unnumbered equation. Okay, this is not an inline environment, specifically for unnumbered equation. Okay. Now you can write whatever equation you want in this case. So you also try this. You can also try it. So we'll try examples of some equations and we'll also come to the integration and all these things, whatever you want. Okay. So you can try some equation. So for example, I know this equation of a wave y equal to a slash sine, okay, bracket kx minus slash omega t. So what is the output that you get? Y equal to a sine kx minus omega t. So you can also try some equation. You can just create an equation of your own. Y equal to, can you write the equation of a circle? I don't know, everyone does not know, but you can just, for example, equation of a circle. Suppose I have to write this equation. You can try this. You can try your own equation because x squared plus y squared equal to constant. And let me write it something like this, slash math rn constant. So the radius is constant. So something like this. X square plus y square equal to constant. Now note, constant is upright, exactly like the line which is above, the text which is there, because of the math rn command. So just try one or two equations. Okay, so now before we go to integration, let's just see one or two things. Now, many times in maths, I think you are also using, let us say, the value of n equal to 1, 2, 3 up to n or something like that. Have you come across that? So, for example, I write the equation something like this: y equal to cos nx, okay, comma, slash, because I want to give a space, let us first compile this. y equal to cos nx. Now the value of n is supposed to be an integer. So let us say I say an integer from 1. So 1, 2, 3, and maybe you have noticed you normally write this something like this, dot, 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 something like that, and up to capital N. Okay. Now how to write this properly? So you have this command slash L dots. Let us compile this. Slash L dots. Correct? So y equal to cos nx, n equal to 1, 2, 3 up to n. So dot, 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 that is given by the command slash L dots. Now let us try another equation and then we'll see the difference between the two commands. Let us say the sum of some series or something like that. Okay. S equal to a underscore 1 plus a underscore 2 plus a superscript. Now instead of L dot up to, let us say plus a capital N. So now I will use slash C dots. Okay. So let us say. Now what do you get? Now do you see the difference between the two dots? The first example of the dot is like a line at the bottom. The second example is like a line in the center. So suppose you want to use this with the plus or something like that, you can use this type of command slash C dots. And suppose you want to write a line, you can write slash L dots. So I think let us quickly practice this. You try this, whether you are getting it or not. So I think now you have got how to write powers, because someone was asking how to write integration, summation, fractions, powers. So powers is now I have told you that you have to how to raise superscript and subscript. Okay, I had already discussed it. Okay. So you also try this, just 1 or 2 minutes. Okay, so have you written it? Yes. So let us practice this one by one. Let us take about a minute. You do it on your own. Okay, so now if you have done this, can we go forward? Yes, can we proceed now? Let us go to our integrations and all those things. Okay. Let me again mention a few things before we go to this thing. So suppose someone will use vector or something like that. So suppose you want to write vector slash vec, let us say u or v, and we compile this. You get a u with a arrow, so slash vector, or you want bar or something like this on your Okay, so you can get slash bar. Okay, let us try these few things. Then let us say you want u dot. Many times for derivative you use the symbol dot above a particular variable. So you get this u dot. Okay. Then if you want double dot, you can use d dot, something like this. One more dot. Normally you don't use triple dot and four dot, something like this, but yeah. Therefore, then suppose you want underline or overline. So you can say you can do this something like this. Underline. Yes, you get an underline. If you want to do overline, okay, so you get something like this. Overline. Okay, so what is the difference between overline and bar? So for example, you do this slash bar curly braces u plus v. Okay, and then you write slash overline curly braces u plus v. Let us see what is the difference you get. So bar is just for one symbol, but if you want the complete thing under your line, then you have to do u plus v overline. Okay, so these are the few symbols. You can use different symbols like hat. You can combine the two symbols. So for example, overline slash dot u. Okay, then you will get something like this. U dot plus v, and above that you get the overline. So you can interchange these symbols. Then there are many other things. Tilde is there. Then hat is there. Somewhere people use hat as an operator. So any particular doubt regarding this? Okay. So let us come back to, so now suppose you want to do certain specific things like integration and differentiation. So let us,
So,
yes.
can you tell me how to write limit x tends to infinity of a function?
Yeah, sure. We'll come to that. So for example, let us say we want to write integration. Okay. So y equal to slash integration. So sorry, let us use integration and let us say cos x. So cos of x, and then you will write dx. So there is no special symbol for dx as such, but let us use this. So what we get here? Y equal to cos x dx. Of course, if you want a space, then you can write something like this. Okay. Y equal to cos x dx. So you are given a space. Now, of course, this is like an indefinite integral, but suppose you want to integrate with a proper limit. Okay, so then what you will do? So what you will say is slash int underscore 0 raised to 2 slash pi. I think you understand that this must be a command for pi. Let us see the result here. Y equal to integration 0 to 2 pi cos x dx. Can you tell me why this error is there? 2 is here the upper limit and pi is there in the integration, whereas I want it here. That error is because when I write raised to, if I want a multiple expression, it should be curly braces. Yes, correct. It should be curly braces. So now let us see this. Y equal to integral 0 to 2 pi cos x dx. So can you write an equation like this now? You can try your own equation. You can write certain limits. You can write your own limits and then do it. And you can interchange this because it is not that, let us say, probably I have not tried this, but you can also try something like this. Raised to 2 pi underscore 0. So let us try this also, because in many cases it gives you the proper result. So see this. So the lower limit I am giving as an underscore, the upper limit I am giving as a power. Okay. So 0 to 2 pi. So whatever lower limit is there, you give underscore, and whatever higher limit is there. But it is a good practice to first write the lower limit, then write the upper limit. So underscore 0 and then upper limit. Of course, if you have a bigger expression, then of course you have to give the curly bracket. Let us say minus pi to pi. So y equal to integral minus pi to pi cos x dx. So I hope you are now comfortable. Maybe you can take 1 minute, try a few things. Then we'll go to yes. Okay. Now, instead of integration, suppose you want to do summation. Any guess what we will change? We will do. We'll use the slash sum command. Slash sum. You see this? Second slash sum command. Okay. Of course, we have to write proper mathematics. So summation of cos x has no meaning. So maybe summation x equal to, sorry, summation is normally n equal to 1 to capital N of, there is no dx in summation. So let us say some a n, or let us say some x n. So now you get the summation. So summation n equal to capital N of x subscript n. You can combine the subscript and superscript. So for example, you want x square n. So maybe you can do something like this, x square n. Or you may also do something like this, which will turn out slightly different, but almost the same thing. X square n. You can do either afterwards or before, but maybe it is a good practice to, whatever you have to write, and then x square n, whatever it is gives the same result. So maybe you can try your own expressions. So here maybe because it is a sum, I will use capital S. S equal to sum of x square n from n equal to 1 to capital N. Of course, whatever sum you want to do, you want to put infinity or something like this. Yes. So have you tried it? Now, let us, as someone had asked, how to write limits. Again, it is simple. I think you will be able to do it. So let us say, so this is a good point to introduce fractions. So let us write down the definition of a derivative. Slash fraction. Immediately when I write fraction, I am getting a 2 curly brackets because there is a numerator and denominator. So the numerator has to be first bracket, dy by dx equal to, what is the definition of this thing? Slash limit. So whenever I get limit, again, I have to write it as delta x tends to 0. So I write this slash delta x slash right arrow 0, and then I write next. So it is a good slash frac slash delta X, capital X D slash delta, sorry I have written wrong. So let us see what you get. Okay. So forget about the mathematics, whether it is correct or not. Those mathematicians you decided. But now I have written an equation which is giving me this limit. So how to write the limit? There is this limit function. There is this limit function, and limit function has only one argument because you don't write any upper index or upper limit. Underscore whatever limit you want to write. I want to write delta x tends to 0. So tends to means I normally use right arrow. So therefore I have used the right arrow. Delta x, naturally I am using a capital delta here. Delta x and my argument. Now how I have written the argument? In this case, now I have introduced the fraction concept. So slash frac, two curly braces, numerator and denominator, and here also slash frac, two curly braces, numerator and denominator. So dy by dx, limit delta x tends to 0, delta y by delta x. Okay. So regarding mathematics and equations, symbols, how to write the symbols, most of the tricks or most of the difficulties I have introduced. Just a minute. Yeah. So now you can, I think, design your own equation. I hope everyone. You can try equation. I will wait for 1 minute. You can try an equation. And if you have a doubt, you will ask me. So there is some doubt about curly braces. I will come to that. Brackets is remaining. Okay, so I will cover the brackets. Yeah, so please try your own this thing. Try your own equations. I'm just waiting 1 or 2 minutes. I'm here available. You can try your own equations and see if you have any problems in that. Okay, now let us come to our again an important part. So many times you have to use brackets, right? So using brackets is quite simple. So normal round brackets. So let us say I have written this and I have written this right bracket. So what do I get? Let us see. So I'm getting brackets, good. But maybe you want brackets which cover everything of the fraction, right? So the brackets which adjust according to the size of whatever is written in the brackets is given by this command left and right. So you write this bracket and you write slash left round bracket, and then you write here slash right, sorry, round bracket. Now you compile this and see what is the difference. Do you see the difference? Now this bracket covers whole of our fraction. It does not mean it is giving a bigger bracket. A bracket which can adjust according to the text inside the braces. Now square bracket and curly braces basically have a certain meaning in Latin. So if you have to use square and curly braces, you always have to use slash right then this brace, and slash left, and this brace. Okay. Or simply you can use slash braces also, but anyway. Sorry, so there is some error. Why is there round bracket coming here? Okay, so you are getting this curly braces. Okay, now in LaTeX, as I said, these square braces and curly braces have certain meaning. So therefore, you always have to precede this with a backslash. Okay, so left curly braces, right curly braces, and you will get this curly braces. So this is about brackets. Okay, now before we go to how to find something about LaTeX. Let us do a Google search and let us say you don't know a spelling or you don't know a symbol. So how to find it? Okay, so just type. Let us say we have done this integral. Okay, so let us say integral symbol. Now when I type a particular symbol or something like this, immediately it is giving a search in LaTeX. Integrals, sums, and limits. So the first search of help is getting overleaf. Int LaTeX symbol. Okay. Slash int is rendered as this curly integral inside math mode. So it means if you want to search something about LaTeX, just type this symbol for LaTeX. It will give you that particular symbol. Now I think I have covered most of the part. Is there a, one more thing is there, but till now, does anyone have any doubts? Anyone? You can, now I have not covered all symbols because it is not possible, but I have covered some basic things. Yes.
Sir, in summation sign, you wrote x to the suffix n.
Yes.
Sometimes we have x to the suffix n and again suffix I, x and I. And how
Yes.
to write this?
So then you will have to write it inside braces.
Inside braces.
Yeah. So you create a, so let us say, so suppose you write this something like this, x raised to 2 underscore n. So this will give you x square n. Right. But suppose you want to include something like this, x underscore n underscore I, something like this. Then what you do is you do it inside braces. Then you compile this. Then you will get this x n I.
Okay.
That was your question, right?
Yes, yes.
And
yes.
instead of, suppose you want to write n square inside the subscript, then you raise this and write square. So now you will get n square. Now it is not x square. Now it is n square in the subscript. Correct?
Understood. Understood. Thank you.
And the same thing you can do for the this thing also. Suppose you want to write x raised to n and raised to square. So you write this in curly braces. So it will do square and square. Okay, x n square. Okay, so I wanted to cover matrix, but I will cover matrix afterward if there is time. What I will do is I will cover another thing. So these equations which I have all given, there were no numbers to this equation. Okay, but suppose you want numbered equations, then what you will do? You will use something which is called a equation environment. So what is that equation environment? Let us see. So I will go through this quickly because, so instead of this, what I will write, instead of this, I will do slash begin equation. Okay. slash begin equation and end equation. Now suppose I write a equation y equal to f of x. Now this has given me a number 1. Y equal to fx is 1. Suppose you write another equation slash begin equation. Then let us say f x equal to x square. Okay. Then this will give me another equation. Okay. Fx equal to x square. Now, so you can also try this. I'll just wait 1 minute. You can try this on your own. Suppose you're getting it. Okay. Now, naturally, whenever there is a number, you have to refer to that number. So let us say I give here a label, definition of a function. Let us say label definition, and let us say label function. Okay. And let me here write substituting equation in brackets slash reference, substituting x square in equation, just forgive any spelling mistake, slash reference function. Okay, we get whatever we get. Okay, now what we get? Sorry, did I make a mistake? Oh, sorry, I made a mistake. Huh? Definition. Substituting equation 2 in equation 1, we get. Okay, now we have not specifically written any equation or something like that. So what is the advantage of this? Suppose I write another equation here, slash begin. Okay, equation. Okay, let us say z equal to gx. Okay, and let me compile this. Now see what is happening here. Okay, there is a equation created which is number 2. Naturally, the equation of the number of the last equation, earlier equation, which was 2, naturally it has become 3 automatically. And in the reference also, our substituting whatever our concept was there, that you have to substitute fx square in y equal to fx. That is automatically changed, substituting equation 3 in equation 1. So you don't have to worry about changing numbers, like suppose there is word, then you don't have to worry about changing numbers. You just refer to that particular label which you have given, and then you refer in that particular text. The number already automatically changes in your text, number for your equation, and so on. Just a side note, it is always a good this thing to. So there are equations, there are tables, there are figures. So whenever you label, you can just label it something like this: equation, name of the equation, and label the category also, so that it is easier to identify. You don't make a mistake. So let us say I am just giving here equation, and here. Okay, so this is about equations. So is that okay now? Any doubt, particular doubt in this? Anyone? Maybe I think today's session was a little fast. There is one last thing which I will cover. Just 1 minute. So till now, if anyone has any particular doubt, just take a minute. You can try on your own and then yes, what is the doubt? So partial differential, there is just a symbol. I mean, there is nothing to cover in this. Let me just do it here. Slash enter slash. So you want to write partial derivative, you can simply write slash par, basically. Just a minute. Slash partial. So first you do this slash frac slash frac. So this was this slash partial y slash partial x. Okay, then you combine this, you will get partial derivative y by x. So these are basically symbols. So now I think I just want to make a last statement here that LaTeX is not a it is not Mathematica or it is not MATLAB. There are no, there is nothing is operating on anything. It is just a symbol. So you just tell it and write the symbol. It is not finding derivative. It is not finding anything. It is just a text making document. Okay, just a better text making document. So partial derivative, just write slash fraction and just write the command for the partial derivative, which is slash partial. Okay. Similarly, you can do for equations and all those things. Any other doubt? So let us just quickly cover another thing. Okay, so suppose you are solving an equation, y equal to something, then you do something equal to something. Okay, so you write 2-3 lines. Now it is not possible to align it. How to align this particular equation? So for that there is this particular environment which is equation array. Okay, so let me just do this. So let us say y slash begin equation array. Okay. Now again, there are a lot of various tools for equations. I am not doing this without using any external package. So let us say y equation array y equal to what should I write? A or x plus y whole square. Sorry. Now you want to expand this bracket. So you want to write equal to x square plus y square plus 2xy. Okay. So let us first see what we get. Maybe we'll get an error first. Okay, without any error we are getting. So what are we getting? Y equal to y, x plus y square equal to x square plus y square minus. Did I make a minus there? Sorry. Now, how to get it exactly as I written here? Okay, so there is a trick here. First, you write here and. You remember this and? We had used this in tables. And. Okay. So now you have told it that there are these particular tabs that you have to keep. And. Then you use and. Then what you do is you go to the next line. Let us see what happens. Now are you getting proper aligned equation? Y equal to x plus y whole square equal to x square plus y square plus 2xy equal to this, equal to that. You can go on and go on and go on. Just one problem you see, each line is numbered. 1, 2. If you don't want that, what to do is slash no number. Okay. And then you compile it. So now you get y equal to x plus y square, x square equal to x square plus y square plus 2x. So this is something called the equation array. There are a lot of packages. There is for equations, there is a very good package called IEEE Tran Tools. So a lot of tools are there. You can search it, IEEE Tran Tools. So let me type here, IEEE Tran Tools. Okay, so this package without any space. Use package, you can search about this IEEE Tran Tools for equations. A lot of very good package. I have used it. Now I don't remember all the commands. So yes, any doubt up to this point? Yes. Any particular doubt? Okay, let us just come to last point. I want to write how to write matrix. So let us use our equation environment, not equation array. So I think you type it first. Sorry, I forgot to say that. You just type it, see if you are getting it on your own, and then we'll go to this last part, matrix, and then I think we'll stop. So are you trying this? Please try it on your own. If you are not getting anything, you can write in chat and let me know. Okay, so let me quickly cover matrix. So suppose you want to write a nice matrix. Okay, let us say x11, x12, x13, y11, y12, something like this. So let us write this matrix. Okay, let us write a matrix in a proper equation. So begin equation, equation environment. Let us say the name of our matrix is maybe something x, capital X, okay, equal to slash begin array. Okay, you have to use this command array. Now immediately when you use array, it is giving CC. So it requires what is your matrix. Okay, so let us say we have to type a 3 by 3 matrix. So what we'll do is we'll make 3 C. So 3 columns. Okay, and then we'll type our matrix. I think let me take this X 1 1. Let us, or maybe I will type a 2 by 2 matrix. It is necessarily typed. So 2 columns X 1 1, 2 by 2 matrix, 2 column 2 rows, X 1 2, X 2 1, X 2 2. And let us see, this gives the proper system. Okay. So are you getting it? X equal to X11, X12, X21, X22. Let me just not worry about numbers because unnecessary formatting problem is there. Let me worry about simply equation. Okay. So try if you are getting it. x equal to x11, x12, x21, x22. Now, I think whenever you write a matrix, you give it some value, some bracket. So slash left and slash right, and then end it. Sorry. After the array. Yes, x equal to x11, x12, x21, x22. So this is how you write matrices. Now, if you want square matrices, if you want determinant, you can just give a vertical line and so on. So I think I have covered most of the things. Any particular doubt? Still wait 1 or 2 minutes. Any particular doubts, you can open up for discussion. No one has, any this thing. So the maths and so now I think you know the equations, tables, and figures, and all these things you can combine and you can prepare a LaTeX document. So I think I have finished from my part. If any doubts or any particular question you want anything else to discuss, we can discuss it for 5-10 minutes. You can just ask. I think separate packages you can search on Google or according to your requirement, because everyone has a different requirement. So all packages we cannot cover. But of course, for image you require graphics package. So naturally you had to use it. There was no option. So anyone else? So I think those who are coordinating, please over to you. Any particular?
Hello, am I audible, sir?
Yes, madam. Please.
Okay. Thank you, sir. I take immense pleasure to sincere thanks to Sandeep, sir, for giving informative information to participant. Thank you so much, sir, for your guidance. Tomorrow on the same times again, we have to join the session. Attendance will be available on WhatsApp group and Telegram. Thank you, sir. Thank you, everyone.
Thank you very much.
Yeah.
Thank you.